You clicked because you can feel it too. The Atlantic just went quiet in the wrong way. Not calm, loaded. Here is the single thing I need you to understand right now. The forecasters I follow are watching the warmest stretch of ocean in the entire hurricane calendar line up with the exact weeks the Atlantic historically does its worst work. That is not my opinion. That is what the National Hurricane Center and the seasonal teams at Colorado State University have been signaling in their own bulletins. And I want to be honest with you about the moment this stopped feeling routine to me. I refresh the National Hurricane Center's tropical weather outlook almost every morning with my coffee. And a few mornings ago, the map that had been clean for days suddenly had color on it again, out in the open ocean between Africa and the Caribbean. That little shaded blob is where the season turns. So here is what I am going to walk you through, minute by minute, in the order it actually matters. I am going to show you what the water is doing, what the models expect over the next several days, and then I am going to give you the one measurement buried in the ocean data that almost nobody in the mainstream coverage is talking about, the number that decides whether a storm stays weak or explodes into something you have to run from. Stay with me, because that last part changes how you should read every headline for the rest of this season, no matter where you live. Let me start with the calendar, because the calendar is the whole story. The Atlantic hurricane season officially runs from the 1st of June to the 30th of November. But those 6 months are not equal, not even close. If you plot every Atlantic storm that has ever been recorded and stack them by date, they pile up into a sharp mountain, and the very peak of that mountain sits on the 10th of September. That is the statistical center of gravity of the entire season. Colorado State University's tropical team, the group Philip Klotzbach has helped lead for years, points to this same window every single year. Roughly the middle of August through the middle of October is when the Atlantic produces the overwhelming majority of its major hurricanes. Therefore, when I tell you the basin is heating up, I am not being dramatic. I am telling you the clock has entered the exact hours it was always going to be most dangerous. We are inside the window right now. But timing alone does not make a hurricane. You need fuel. And that is where the ocean comes in, and where the picture stops being ordinary. A tropical storm is, at its core, a heat engine. It runs on warm water. The rule of thumb that forecasters have used for decades is that you need sea surface temperatures of about 26 degrees Celsius, which is around 79 degrees Fahrenheit, running down to a meaningful depth before the atmosphere can build and sustain a warm core storm. Below that threshold, thunderstorms, fire, and fizzle. Above it, and with the right conditions overhead, they can organize, spin, and feed on themselves. Right now, across the tropical Atlantic, the water is not at the threshold. It is well past it. Through the heart of the season, the main development region, the stretch of ocean between roughly 10 and 20 degrees north latitude reaching from the coast of Africa toward the Caribbean, routinely sits in the range of 28 to 29 degrees Celsius, which is around 82 to 85 degrees Fahrenheit. That is not a threshold. That is an accelerant. And here is the part that made me sit up. It is not just that the water is warm. It is how consistently warm it has been across the whole basin for stretches of recent seasons. NOAA and multiple ocean monitoring groups have documented Atlantic sea surface temperatures running at or near record highs for the time of year. When the entire tank is topped off this early in the peak, the ocean stops being the limiting factor. The brakes come off. From that point on, the only thing standing between a harmless cluster of clouds and a named storm is what happens in the air above it. So let me take you up into that air, because this is the tug of war that will decide the next several days. Warm water wants to build storms, but the atmosphere can fight back. And it has two main weapons. The first is wind shear. That is when winds at different altitudes blow at different speeds or directions, and they tear the tops off developing storms before they can stack into a tight vertical column. Strong shear is a storm killer. The second weapon is dry, dusty air. And this is where I have to introduce you to something most people have never heard of, even though it flies over their heads every summer. It is called the Saharan air layer. Every few days through the summer, a mass of hot, bone-dry, dust-filled air lifts off the Sahara Desert and rides the winds westward out over the Atlantic. This dusty plume does two things that suppress hurricanes. It chokes off the moisture that thunderstorms need, and it comes wrapped in a strong burst of mid-level wind that adds shear. NASA's Earth Observatory has published stunning satellite images of these dust clouds stretching thousands of miles across the ocean, sometimes all the way to the Caribbean and the Gulf. In June and July, this Saharan air is one of the biggest reasons the Atlantic often stays quiet, even when the water is warm. But here is the shift, and this is the whole reason I am talking to you today. As the calendar moves deeper into the peak, that Saharan air layer typically weakens and pulls back. The dust thins. The atmosphere over the main development region moistens up. And suddenly, the tropical waves rolling off Africa, the very same waves that got shredded in July, find themselves moving over record warm water with far less to stop them. Therefore, the danger is not just that conditions are bad. It is that they are changing in the storm's favor, right now, in real time. The referee that has been calling off the fight all summer is leaving the ring. Let me make this concrete, because I do not want you to walk away with a vague sense of unease. I want you to know exactly what to watch. Those tropical waves I keep mentioning come off the west coast of Africa on a fairly regular schedule during the peak, often every 2 to 4 days. Forecasters call the storms that form from them near the Cabo Verde Islands, the Cabo Verde systems, and they are the ones that matter most because they have the longest possible runway. A wave that becomes a storm way out near Africa has thousands of miles of warm open ocean ahead of it. That is time to organize, time to strengthen, time to become a long-track major hurricane before it ever reaches land. The National Hurricane Center tracks exactly this in a product you can read yourself for free, updated every 6 hours. It is called the Tropical Weather Outlook. In it, they mark areas of interest and assign each one a probability of development over the next 2 days and the next 7 days, color-coded from yellow to orange to red. Yellow is low. Red is a system they expect to become a depression or storm. When I saw color reappear on that map after a stretch of quiet, that 7-day cone of possibility is precisely what I was looking at. Now, let me pause here, because I know exactly what a lot of you are thinking. You are thinking, this is a coastal problem. You are thinking, I live inland, I live in the middle of the country, I live somewhere the ocean never touches, so this map is somebody else's emergency. This next part is for you specifically. Please do not skip it, because the assumption that a hurricane is only a coastline event is one of the most dangerous misreadings of these storms, and the data proves it. Here's what the science actually shows. The deadliest part of a landfalling tropical system, historically, is very often not the wind on the beach. It is the water inland. When a hurricane or even a weakened tropical storm moves ashore, it does not simply stop. It carries an enormous load of tropical moisture inland and wrings it out over hills and river valleys, sometimes hundreds of miles from where it made landfall. The National Hurricane Center's own long-term analysis of storm fatalities has repeatedly found that a large share of deaths in recent decades came from water, and a big piece of that from freshwater flooding well away from the coast, along with the drowning risk in inland flash floods. Think about what that means. A person who evacuated the beach can be safe, while a person 200 miles inland who never gave the storm a second thought can be caught in rising water overnight. Rivers crest a day or two after the rain, so the flooding peaks long after the storm has been downgraded and dropped out of the headlines. That lag is exactly when people let their guard down. So here is the concrete thing you can do wherever you are. First, find out right now whether you live in a flood-prone area, and you can check that against the flood maps the Federal Emergency Management Agency publishes. Second, Whenever a tropical system is anywhere in the forecast for your broader region, do not just check the wind category. Check the rainfall forecast and the flash flood outlook from your local National Weather Service office and from the Weather Prediction Center, which issues an excess rainfall outlook you can read online. Third, learn the one rule that saves the most lives in inland flooding, the rule the Weather Service repeats every year. If you come to a flooded road, turn around, do not drown. It takes only about 12 inches of moving water, which is a single foot, to float many vehicles, and about 6 inches, which is only knee height, to knock an adult off their feet. Those are not scare numbers. Those are the measured thresholds. And there is one more thing you can do today that costs nothing. If you have not already, look up whether your phone has wireless emergency alerts turned on. Those are the alerts that let the National Weather Service push a flash flood warning or a tornado warning directly to your screen, even in the middle of the night. In a fast-moving inland flood, that buzz on your nightstand can be the difference. Tropical systems spin up tornadoes too, often in their outer bands, well away from the center. So this is not only a coastal setting. So now you know the calendar is at its worst point. The ocean is overloaded with fuel, the atmosphere is shifting to let storms through, and the danger reaches far inland. That should already have your attention. But I promised you a specific measurement, the one buried in the data that decides everything, and I have not given it to you yet. And that is the piece I most want you to remember. But before I get there, I want to point you towards something that goes even deeper. If you want to understand these storms at a level the headlines never reach, I put everything I know about reading tropical systems, the signals, the data sources, and the decision frameworks that matter most into a series of digital books called Storm Signal, Storm Intelligence, and Storm Alert. They are built for exactly the kind of person watching this video, someone who wants to understand the ocean heat map before the reporter is standing in the wind. You can find them linked in the description below, and I think they will change how you follow every storm for the rest of your life. Now, back to that measurement buried in the data, because this is the part that changes everything. Here it is, and it is the part I most want you to remember. For years, when people talked about hurricane fuel, they talked about sea surface temperature, the temperature of the very top of the ocean. But the surface is only a skin. A storm churns the sea violently as it passes, and that churning drags up cooler water from below, which can actually starve the storm and weaken it. So the real question is not just how warm the surface is, it is how deep the warm water goes. Oceanographers measure this with something called ocean heat content, sometimes described through the tropical cyclone heat potential. It captures how much warm water is stacked up beneath the surface all the way down to the depth where the ocean finally cools to 26 degrees Celsius. When that warm layer is thin, a storm churns up cold water and puts on the brakes itself. But when that warm layer is deep, the churning brings up more warm water and the storm just keeps feeding. There is no cold water to save you. And this is the detail the mainstream coverage keeps flattening into one word: warm, when the real story is depth. In parts of the Atlantic, and especially in the Caribbean and the Gulf, there are features where warm water runs unusually deep. In the Gulf, one of them has a name that forecasters watch like a hawk. It is called the loop current, along with the warm eddies that pinch off from it. These are pools of deep warm water, and when a storm crosses one, it hits an afterburner. That afterburner has a name too, and it is the number I want burned into your memory. It is called rapid intensification. The National Hurricane Center defines it precisely. Rapid intensification is an increase in a storm's maximum sustained winds of at least 30 knots, which is about 35 miles per hour in 24 hours or less. 35 miles per hour of extra wind in a single day. Let me put that in human terms. That is a storm you go to sleep thinking of as a manageable tropical storm, and you wake up to a full hurricane. That is a moderate hurricane on the evening forecast, becoming a monster by the next afternoon. And the ingredient that most reliably powers that leap is exactly what I just described: deep Warm water with no cold layer underneath to interrupt it, sitting under an atmosphere that has finally shed its shear and its Saharan dust. This is the signal that has been sitting in the ocean heat data all along, and it is why the calm you feel right now can be so misleading. A quiet map does not mean a safe season. It means the fuel is accumulating with nothing burning it off. The most dangerous setups in Atlantic history have often come from storms that formed in an environment primed for exactly this kind of explosive strengthening close to land, when there is no time left to react. And that is the piece I need you to carry out of this video. When the next system does form, and in the peak weeks, it very likely will, do not anchor on the category you see when it is far away. Ask the question the specialists ask. What is the ocean heat content along its path? And is it heading over one of those deep, warm pools before it reaches land? Because a storm can go from something you would watch to something you must flee in less time than it takes to get a good night's sleep. That is not fear. That is the measured, defined behavior of these systems, straight from the agency that names them. Let me pull the timeline back together so you have it clean in your head. Right now, this moment, the Atlantic sits at the statistical peak of its season, with the 10th of September as the center of the danger window. The ocean across the main development region is running warm, in that 28 to 29 degrees Celsius range through the heart of the tropics, well above the roughly 26-degree threshold storms need. That is the fuel already in the tank. Over the coming days, the pattern that has been holding storms back, the Saharan air layer, and stretches of hostile wind shear tends to weaken as the season deepens. As it pulls away, the tropical waves rolling off Africa every 2 to 4 days lose their biggest opponents. That is the shift, and it is the reason a quiet map can flip. And then, if a system organizes and tracks toward the deep warm water of the Caribbean and the Gulf, the ingredient for rapid intensification is on the table, a jump of 35 miles per hour of wind or more in a day. That is the escalation, and it is the part that decides how much warning real people actually get. So what do you do with all of this? You do not panic. You get ahead of it the same way the people who read the source data do. Bookmark the National Hurricane Center's Tropical Weather Outlook and check it yourself, especially through September and into October. It updates every 6 hours during the season, and it tells you in plain color code where the next system might come from. When you see an area go from yellow to orange to red, that is your cue to start paying real attention, not when it is already a name on the news. Follow your local National Weather Service office and the Weather Prediction Center for rainfall, because if you are inland, the rain and the rivers are your threat far more than the wind. Watch the flash flood outlooks. Know your flood zone before there is ever a cloud in the sky. Make sure your phone's wireless emergency alerts are on tonight, not next week. Those alerts do not care whether you were paying attention, they will wake you up. And if you live anywhere a storm can reach, coast or inland, decide now, in the calm, what you will do and where you will go if a system heads your way and starts to strengthen fast. Because the whole lesson of rapid intensification is that the calm is when you plan, since the storm may not give you a second calm window to do it in. Here is the emotional truth I want to leave you with. The scariest thing about these storms is not their strength, it is how quietly they assemble the pieces before anyone is watching, and how fast they can turn once every piece is in place. You now know how to read those pieces. To watch the depth of the warm water, not just the surface. The dust and the shear are the brakes, and when the brakes come off. The water inland kills more than the wind on the beach. That knowledge is what keeps you one step ahead of a headline that always arrives a little too late. You are the kind of person who would rather understand the ocean heat map than wait for a reporter to stand in the wind and tell you what already happened. That is exactly who I make these for. So tell me this, and be specific. When you look at the setup I just described, the deep warm water, and the rapid intensification threshold of 35 miles per hour in a day. Does it change how you have been reading this season so far? Drop your answer in the comments and tell me where you are watching from, whether you are on the coast, deep inland, or somewhere the tropics have never reached, so I can get a picture of how this is looking across all of your regions. I read them, and the local details you share often sharpen how I track what comes next. If you want the real, sourced update before it becomes a headline, this is where to get it. Subscribing means you are in the group that reads the data early instead of reacting late. And keep your eye on one thing with me over the next stretch. I am already tracking how those tropical waves are behaving as they leave Africa, and whether the Saharan dust is finally thinning on schedule, because the first system that finds deep, warm water with the brakes off is the one that will tell us what kind of peak this season really becomes. I will be watching the source data the moment it updates, and I will bring it straight to you. You're still here, so this one's for you. Inside the Weather Watch, I pick up right where I stopped, with the ocean heat content number that predicts rapid intensification laid out in full. And you can ask me your own question. A real person, me, answers you, not a bot. You belong with the storm watchers already inside. Just point your phone at the code on screen. Cancel anytime with one click.